Hello, everyone. I'm Alan Willard, developer relations technical artist here at Epic Games, and I'm going to be talking about things you can do with displacing meshes. Most of it I'm going to kind of center around something I've been working on for Unreal Tournament, which is a kind of Ghostbusters style link beam effect. Using Vertex Displacement to give it simulated loops and curls without going too far, but using a really simple setup. So I've pre-built a few things in a separate project, which I've got open here. A few things that I want to kind of cover first are coordinate spaces is kind of the most important. There's three primary coordinate spaces. World coordinates, which is purely what it sounds like. It's where is something in space. In the material editor, this shows up as a series of colors. So here, this is tangent space, which I'll get into for a minute, but I'm converting that to world space. So compile this, and you'll notice that there's this kind of four-way cross of colors. This is because each position in X, Y, and Z is rendering into a color value. If something is 15 units down X, that value will be 15, which in color space would be really bright and glowy. Since the sphere is in the center, all the values are pretty close to zero. And then they go negative on the opposite side. So that's why in this case, blue is the Z value. So the higher something is or the lower something is, its value will change correspondingly. If I just compile this and throw it on my ground plane here, you'll see the coordinates show up there based on what direction it's facing. If I throw it on something that has a little more visual interest. So this is what direction is the surface facing. If I give it the world position, there we go. So this is the actual position in space per pixel. So compile this, and now as this moves around, it will become insanely bright in one color or another based on its position in space. As I get to the center of the world, you'll see it zeroes out and I get that funky color, but now it's actually based on the individual pixel's position in the world. So we use these kind of values to determine how we want to disrupt the surface of the object. If I go ahead and change this to tangent space is the coordinate of the pixel, or the vector that the pixel is facing based off of the surface. So by default, it's a unit length vector of 1 out from the surface normal. So that looks like this blue, 0, 0, 1. So we're facing completely out from the surface. It's how we do basic lighting, specular reflection, things like that, is using that surface normal. When you get to something like a normal map, like this, would help if I actually added it. And texture sample. So this normal map that you see here, I can open up here, all this is doing is saying the surface really goes straight out from the normal, but we're going to adjust that per pixel so that the lighting calculation will change. And that's how we do detail lighting and things like that. And playing around with that, we get some funky effects. If I set my color to be gray, get rid of the emissive value, and just pump this directly into the normal map, you'll see my lighting shifts as I move it around based on the normal map I'm applying. And all we're doing is messing around with the results of that surface's normals. The material editor, by default, takes everything that's in tangent space hooked up to the normal, converts it to world space for you, and then applies it to the world, which is why if I compile this and change the view mode to world normal, That's why this looks the way it does, because the results of this, which would look something like this, this is exactly the same data. However, the material editor, or the material after, as it's being compiled, is converting the normals into world space. So the lighting is all done in world space. This is important because when you start doing things like displacement, you need to know what coordinate set you're in. World space means that you're getting the value based on what direction the surface is facing in the world, which is, again, what this looks like. So this is purely, am I facing positive z, positive x, positive y, negative y. We use this kind of value pretty frequently for doing things like putting snow on tops of rocks. If you were to just use the blue channel, which is z, we'll mask it out to just blue and put that as the emissive color. And set no lighting so we can see it clearly. I will only get a value on the top of the sphere. No matter what I do to the sphere, if I rotate it around, these values will always be positive up. If I clamp it and start messing around with the math, increasing the power, the mult, clamping it, things like that, I can get something that is a very tight mask on, say, just the top. So, say a power of 7, and make sure I clamp the results. So now I'll have a mask that is much tighter on just the top. So now if I wanted snow to only hit the top and gently fall off, I could do that. But we can also use these same behaviors to control where and when we're displacing a mesh. Say I wanted the mesh to always displace up. I could take the vertex normal, and this is the same as the surface normal, but it's stored per vertex, so it's a little more efficient to work with. And we'll multiply this by some value. Let's go with 15. And we'll fit this into the world position offset. I now have a bulge based off of that world position mask that is only on the top. So, well, because I'm not clamping it before the power, if I clamp it, having the right fingers on the right keys helps. There, now it's only on the top. So this is good for doing things like actually building up snow on the top of things. So say you have a rock and you want to mound the snow on the top a bit, this can work quite well. And again, as I rotate the mesh, you'll see it always staying on the top. You could also do this to combine with some sampling to do ice coming down from something. So if I then took this texture sample and this one, here we go, and we'll say this is going to have pretty high tiling value. We'll look at this on the there we go. So say we wanted ice spikes to grow up. I could modulate my displacement amount by that texture. And now when I feed it in, I'm only going to get the positive values spiking up. So given the tessellation, you only get as much as your actual triangulation for the surface. So this is a case where you might want to add more triangles to the surface to accommodate a special effect like this. So we have a few questions. In every single attempt I've made to make anything with tessellation and displacement, the effect was simply way, way, way too expensive. Are there any ways, future plans to optimize it? Tessellation is about as optimal as it's going to get in the near term. I'm not sure if there's any plans in the near future to optimize it. It is somewhat self-optimizing in that the engine, unless you turn it off, will dynamically adjust the tessellation based on the screen space that the triangle takes up, trying to keep it from being overly dense. In terms of displacement, there's two forms of displacement. I'm using world position offset, which is done per vertex. This is great for doing things where either your mesh is fairly dense already and you don't want to add more detail, or if you're working with lower poly objects or on a project where for one reason or another, whether it's based on the platform, you can't or don't want to use per pixel displacement, which is the other entry here, world displacement. This only activates if you turn on displacement, or sorry, tessellation, which is, if I scroll down here, PN triangles, turn that on, and this means that it doesn't just add more triangles between the pre-existing vertices, it actually fits a spline to try and enhance the curvature, so your silhouette gets more tessellated as well. If I compile that and turn it on and go into wireframe here, once it finishes compiling, you'll actually see the increased tessellation. And as I move in and out, you can see the tessellation automatically adjusting. It tries to keep all triangles on the mesh the same size in screen space, no matter the distance from the camera. So there's no plans to that I'm aware of to increase the performance. It's there's a fixed cost to doing this kind of operation on triangles in the scene. So turning this off for now. Somebody asked how it would make meshes wobble. So we'll get into the specifics of that a little bit, but as you saw, I'm using a texture mask here to clamp where the the displacement is allowed to be. If I, instead of just statically masking, if I add a panner, so that I'm moving this texture coordinate or the mask around, it will now cause the mask to move, so my tessellation results will, or my displacement results will begin to shift around. So this is good for doing something like lava flow, where it's really a static object, but you have shapes passing down it to show where cooler and warmer parts of the lava are, or even something like river water, where you want some undulation to the surface that may or may not be aligned with panning texture information on the surface. So this allows you to have some variability to the surface. You don't want to go too extreme, because while it does change the lighting a bit, it doesn't really change the normal calculations. So if you're doing things in the vertex shader in displacement or world position offset that aren't reflected in what the normals are doing, you're going to see some lighting discrepancies between the two. So going back to the difference between world position offset and world displacement, if I just drag this down and turn tessellation back on, you're going to see the results are a lot smoother and higher density. So now we have a much smoother result going on. And because the way you do the math changes a little bit when you're doing displacement. But now you can actually see the shape of the texture panning through. If I just feed this directly and skip the Vertex Normal, it should actually only appear on the top. Shader compiling. Oh, still wrong. either way. But so vertex displacement, the world position offset is cheaper but lower resolution, or the resolution is fixed to the vertices that you have. World displacement is per pixel. It also gets smoothed by the tessellation if you use PN triangles, which has tessellation and smoothing built in. So going back to the world position offset, turn off our tessellation here. So that's how you would make a mesh wobble. If you skipped doing the masking, so we're just going to feed this directly in this texture. Now the whole mesh is going to move. And now the mesh's animation will be based on the scale of your texture here. So if I change my texture scale to be much smaller, more of the texture is going to be affecting all the vertices as a whole. Or basically your sample size will increase to affect the whole mesh. So now the whole thing will move a little bit. And right now I'm multiplying that by the vertex normals. If I add them to the vertex normals instead, it will animate in a different way. So now it's a little more wobbly. You can see it's shifting its center point instead of just swelling and contracting. As you begin working with this, and I'll show this a little bit, you can start to get three-dimensional motion rather than just kind of based off of the surface normal. So I'll go ahead and start talking about that a bit. So I've pre-built a little bit of a complex material here, and I'm going to go ahead and break it down a bit. So using some of the same textures that I was just demonstrating with, what I've done is taking the world position of the mesh, and this allows me to build a three-dimensional mapping structure. I'm determining what scale I want my effect to be applied to the mesh. And since I'm always working in 3 dimensions, X, Y, and Z, I can use a vector parameter. So just mapping red to X, green to Y, and blue to Z. And then I'm also adding a pseudorandom value as well. I'm then masking 2 coordinates each. So what I'm getting is a 3-dimensional coordinate from the world position. I'm scaling that and adjusting it per instance if I choose, and then I am getting a coordinate set from all the components. So I'm getting the Y plane, the X plane, and the Z plane, and then I'm panning those independently. So each one of the planes moves at a different speed. This is then being fed into the coordinate set for 3 textures, which will end up looking a little like this on the surface. So this is the YZ plane. It doesn't look very good from other angles, but from YZ I have a world space panning noise field. And the same will be true for XZ here, and then for XY. So what I have are 3 separate coordinate sets to combine down, and that's what happens here. I'm appending them together to make an RGB or XYZ result, and that looks like this. So now I have all 3 coordinate sets are being processed together, and this will become my displacement field. And this is in world space, moving through the world and being applied. I then multiply this by 2 and then subtract 1. And what that does is it takes a gradient that normally would go from 0 to 1, makes it go from 0 to 2, and then biases it down so it goes from -1 to 1, which is the gradient, or the value set that we would use for normal maps. And this way I get something that will move not just in positive space, but in negative as well. I multiply that by an RGB value for XYZ, so I can choose how much I want to displace in any given vector, and then I'm multiplying that by some other values here for whether or not I'm doing any masking on the surface, and then that gets fed into the world displacement. The emissive color part of it is pretty simple. It's a color that's being masked by this same little bit here. This piece here is purely just giving me a gradient mask, and you'll see why I'm doing this in a second. So it literally just fades out at the top, fades out at the bottom, and is mostly white throughout the center. So now that I have this, I created a displacement material parameter, or material instance here. So this is just defining the per instance values using that material that I created. And the whole idea of this is we have this three-dimensional noise that's being applied to the surface, which gives it that roiling behavior. And then I've built a specific set of meshes. Let me go ahead and get rid of the sky and the fog. There, we don't need that right now. So here's one of the meshes that I built. It's extremely simple. It's a 10 unit long, 10 unit radius, so 20 unit diameter cylinder. It's fairly dense because I am going to be doing world position offset on it, and I wanted to have enough resolution there that when I do apply my material, it has something to play off of. So dropping that in my scene, bring it close to me here, and now I'm going to scale it along its x-axis. 20. So now, given that it was originally 10 units long, scaling that by 20 means it's a 200 unit long cylinder. And then I'll grab that material instance that I created and apply that to it. And I immediately get this nice kind of bendy, animated tube. And some of the parameters that I've included here, for example, the displacement amounts, if I scroll that, I now have, there's almost no X or Y displacement going on, but there is Z. So you can see I get a waveform going through it. If I increase that, the waveform gets stronger. If I decrease it, it gets smaller. And then the actual scaling value, and this is, if you imagine this to be a texture that's panning across it, the scaling value directly affects the resolution of that ripple. So changing the texture coordinate scaling will change the waveform that's being fed through your mesh here. So I found around 500 makes for pretty good, almost continuous surface ripples. I've also added inside of the gradient, so the gradient mask that I showed off, the reason for that is to keep the ends from wobbling all over the place. If I go into the original material and just kind of step around that masking, just set the value to 1. You'll see both ends are going to go completely with the noise values that are being applied. So now it's not grounded. Well, it would help if I fed that into the right place. So for use with something like a weapon or an effect that's placed in the scene, unless you're specifically looking for something that does this, it goes all over the place, which would be fine if you had it buried in something and you didn't care. But when you're trying to ground it on something and link up secondary things to it, you need something a little more like this, where you've got the ends being clamped. You can add math to allow you to adjust that a bit. Go ahead and hook this back up the way it was. I also implemented some scaling factors. So these values are getting added directly to the vertex normals before the displacement is being done. And what that allows me to do is I have a center swell, which allows me to thicken or narrow the interior. and an end scale, which does the same to the end. So if I want to have it start narrow and get fairly thick, I can do that, or vice versa. So this allows me a little more control over how the effect is going to work. And obviously, if I wanted to, I could set it up on the inverse so that, or set it up discretely so the one end could swell or contract while the other end stayed the same, or vice versa. So does displacement affect per poly collision? No, it does not. This is all being done on the GPU. So think of this as something you need to carefully manage so that your visual does not exceed your collision if collision is important. The way I've done this is on the link beam is carefully keeping the distances narrow. Plus, since the link beam is doing a trace to see what it hits as far out as the endpoint, which I think is 1,000 units or something, anything that interrupts the beam from in that trace would just shorten the beam to that length. And in the blueprint for the link beam effect, what I'm doing is I actually scale this displacement amount value based on the length of the beam. And what that does is it helps to keep it from getting extremely noisy when the beam happens to hit something close. If I set this value to 2, this wouldn't look very good if you happen to be hitting a wall nearby, whereas that looks a lot more like a coiling long beam effect. So to keep it from getting too terribly noisy at short distances and break the immersion, I also scaled the overall displacement factor down based on the percentage of its maximum length that the beam is going. Is the tessellation shown in the link gun beam effect recommended for VR? It has been used in VR in our Showdown demonstration, which I actually talked about in an earlier Twitch stream. We use displacement in place of a lot of translucency to get the explosion and smoke effects. So we use displacement to expand a sphere in kind of a noise fashion, and then use our blackbody node to also set the temperature of the surface based on the amount of displacement. So areas that we're displacing out further tended to be cooler, so those were smoke, so they were dark. Areas that were still closer to the center were considered to be hotter, and so got that reddish glow effect. So given all this, there's a couple different places you can go with this. The link beam tends to have secondary effects along with it. One of those things, of course, being a second smaller beam that twines around it. And the way that I accomplished that was by using different meshes. So I'm going to swap this mesh out for one called twin beam. So this actually has 2 cylinders nested inside of each other, which looks like this. And I was careful to make sure that each of these had its own material index, because if I go into my materials and duplicate my base instance, second beam, I can now do things like change the color, make it red. Let's make it really intensely red. So now it's kind of silly glow red. And here's where that pseudo-random comes into play. So these are offsets that are being applied before any of the displacement happens. So this lets me say the kind of pattern that the noise is being applied is staggered relative to another version of the instance. So we'll take this instance and apply it to the second beam. And now I have 2 beams overlapping that are essentially doing the same animation, just with staggered offsets. And then, of course, in the instance behavior itself, I can say I'm going to thin out the second beam a bit so that we get a really tight coil. And I can go back into the primary beam here and set it back to the default. So now I have one primary beam with a secondary beam threading through. And of course, this is expandable. So I also built a quad beam version. So you can see there's now one primary beam in the center and then 3 secondary beams are on the outside, and obviously doing the same basic idea. 2 and 3. We'll say this one is blue, and another tap in pseudorandom just to bias the offsets. And depending on what I have exposed, I could do this more for changing the pan speeds or change the texture sample so that I get completely different results without having to do a large amount of rework. And let's make this one yellow, and we'll bring the value down to 5. So there we go. One primary beam with other RGB values twining around it, and there's no collision. There's no surface to really work with. They're essentially, from the engine's point of view, these are still just cylinder stretching. So you don't want to go too crazy with how far you allow these things to go. Obviously, you could go into the base material, and any change you make there is going to affect all of them simultaneously. I can go in here and say I'm going to increase my green value up a ways just to match with all the rest. There we go. So now the whole thing glows to a ridiculous degree. But like I said, this is not something, it doesn't actually have a surface. The engine has no knowledge of really what's being done. It's all being kind of done in the shader that the GPU is applying. So how do we do something where, say, a particle system is coming off of this object? So there's a couple of ways you can do that. One is to just assume that the cylinder is usually going to be in the center and kind of come off of that at will. Relying on the fact that you're probably not going to displace it too far and have fairly large particles kind of dripping off. Another would be there. To go into the material, oops, wrong one, and say, I'm going to add a static switch parameter, and we'll call it B particle. And we're going to get the particle color. So it'd help if I could type. And if it's true, we'll use the alpha channel modulated by the masking style. And if it's false, we'll just use the masking style. And we'll feed this into the particle color as well. If it's false, we use regular color. If it's true, we'll use the particle. So one thing to be aware of, with world display or world position offset, doing all this in the Vertex shader, this will work fine. When you're dealing with a particle system, the material has to be compiled for that particles to be used with particles. It's one of the usage flag here with particle sprites. Compile, everything's fine. It takes a second to compile, and then it can be used. If you're doing the world displacement, which this actually is, I need to move this up to. Yeah, so I'll actually show it. These aren't compatible with each other. You can't do world displacement and have it used on particle sprites. So this is a case where you'd want to turn off displacement or tessellation and compile it directly with world position offset. So you'll notice the coiling still happens. It's a little lower resolution because now it's per vertex instead of per poly, but it's still, this again is the reason why I added so many rings to the cylinder, was so that I would have the resolution to do something like this. But now I'm doing it all in the vertex shader, and the particle system can work with that. So in my list of materials here, I'd actually already created one, and I'm going to say that yes, it is used with particles. It will compile itself as well. And now I can go in to a particle system that I'd already created. And let's set the color. Make sure my color is something other than black. Where's my particle material? All right, and let me drop this in and see if I've messed anything up. So now my particles look like they're coming off of the surface of the object. Oh, well, it would help if I applied a material. Yes, even I make stupid mistakes. There we go. So I'll get rid of some of the acceleration and a little bit of the velocity here. So what's happening here is I have the same parent material, this displacement instance. The displacement is happening based off of the alpha channel, or the lifetime. So as the particles die, they become less affected by the displacement. There's no no displacement occurring. Let's go ahead and just skip this completely. Compile again. So a few other questions. You mentioned talking about using displacement on the explosions in Showdown. Do you remember which stream it was, or around what date? No, I don't. It was quite a while ago. How could you fade out a blackbody fireball without translucency? By scaling it back down, basically letting it collapse down. we also did mass dithering, relying on temporal anti-aliasing to fade it out. So basically, the entire thing is opaque, and then it begins to essentially etch away. The dithering node would then essentially increase the chance that any given pixel was being masked out. The temporal anti-aliasing then kind of fuzzes that together, so you get a fade effect that allows you to do kind of a kind of frosted glass fade. Does particle scale surface node work with displaced geometry? No, because again, it's being done. Most particle or most skeletal deformation is done on the CPU, not the GPU, and a lot of the displacement is being done on the GPU. So here we have my particles basically in lockstep. They aren't quite in the same location, but they're essentially in lockstep with the motion of the particle of the surface. If I set this back to be something like 0, they'll actually lose some of their cohesion with the offset over time because its contribution drops off more rapidly. So here you can see, let me get rid of the color contribution. I know what I did here. There we go. I was inadvertently scaling the color as well as the displacement contribution. So we'll set our fade off over life to something a little more reasonable again. So now, about halfway through the particle's life, they are no longer being affected by the displacement. So now when we add something like acceleration and a little bit of spherical behavior, some velocity, we have particles that are being shot off from the surface, but they look like they're actually coming from the mesh. There's a little bit of distortion that happens when they're getting the displacement applied, but that quickly gets lessened down and they become just square sparks again. If I set my initial location to be 500 so that it matches completely, you'll see the waveform that's being applied to displace the mesh is being applied to the particle system as well. So somebody asked, when adding glow to the link gun beam effect, would that glow be per object in the scene or does it need scene glow? Well, if you're doing glow like this, it's per material or per particle system based on what you're working on. So what you're seeing here is a material instance with an extremely large or extremely high value in the color values. So as here, normally this would be 0 to 1. If I just pick a color, this is what you would normally expect to see. By increasing the value, I'm basically taking that value, that color, and multiplying it to a large degree. Over a certain threshold, the post-process settings for bloom start to kick in, and you start seeing this kind of result. So this is just an inherent part of the engine. If you wanted to adjust the settings for this, you could either do it in the world settings for the post or a per volume post-process setting. You can control the bloom values and the thresholds and things like that. Ryan Brooks mentioned once that there would be an optimization to avoid the fixed cost where the tessellation multiplier is 0. Only have one landscape layer tessellated. Any ideas? I have not heard anything about that. Ryan works a lot more hand in hand with the rendering programmers, so I would definitely defer to him on that. And I also don't know whether or not that has actually been done. So it may be something that has been already implemented. It may not quite be there yet. I have no idea on that. So the other part of specifically the Lincoln effect was I don't just do it on this cylinder. I'm actually doing it on a spline and setting the tangents. And this is where something like this particle effect wouldn't come into play as well, because there's no way to accurately model the curvature of the spline before it's actually in use. So if I drop this spline guy in, and let's say just the regular beam cylinder, there. So I can set my positions. You can see the curvature is already being applied, and then when I put my material on, it has to compile because it's now being used for a spline. And once it's done, I should start to get this curvature So the way the link gun beam works is I trace straight out from the gun to find where my endpoint is, whether that's empty space because I didn't hit anything or if I hit the wall. If I hit a wall or any other surface, the way trace works, I can actually get the surface normal, again, the direction the polygon is facing, and I can set that to be my end tangent. So it hits a surface that's angled, it hits it, it gets an arc off of it based on the end tangent strength. So you can see if I increase that end tangent strength dramatically, my effect starts to go way out. So by manipulating how strong that is, I either hit it square and stop the beam, or I can actually curve off of it and have the arc conform to the endpoint of the beam. The first implementation of that was way too strong, so I've backed it down. I also tightened up some of the distances that the spline, the displacement on top of the spline can handle. But this meant that I could have any curvature that I wanted based off of the object that I'm hitting, and then interpolate that as you move. So if you take the beam and move it across a 90-degree angle or any other angle, instead of popping from one to the other, I can actually have it wrap over and look like it's a contiguous beam changing direction rather than snapping and recreating itself the next frame. Am I a wizard? I don't know, Shelley. Am I a wizard? Yes. I am a wizard. I apparently need to get new glasses and shave my mustache, but so this is how a lot of the kind of beam power effects. I've also been playing around with doing stuff like energy arcs, where you randomly find 2 points and just connect something like this between them for whatever length of time you want, or being able to do things like a reactor core effect where instead of being horizontal like this, it would be vertical, and inside of the end behaviors, you'd have the end scale be pretty high and the center swell be pretty low, so that you get kind of a beam condensing down on a center point with a little more math to change the masking style. So the masking style in the base shader, I had 2 ways of solving the problem of the ends not moving around. One was to actually get the texture coordinates and build up a procedural endpoint. So I'm basically hand authoring that, or by just doing it with a texture. And so I've got a flag in for, if it's true, it's using the texture. If it's false, it's using the procedural way. The texture being something that I could easily update and do something that just wasn't a gradient. I could do something more complicated. So there we go. The displacement happening on a vertical surface. You'll notice, because depending on what I'm doing, if I kill certain displacement vectors here, it prevents the beam from trying to loop back on itself, because the displacement isn't happening along the length of the beam, which can be pretty useful. So if I set both the y and z to be 0 and increase this, you can see the beam is basically moving forward and back along its length, which looks really cool here, but when you're, if that's not the effect you're going for, you're going to want to be able to slim that down. So being able to bring that down a bit, you still get some noise, but you're relying on the other two axes to really give you that noisy coil effect between 2 points. So let's see if there's any last questions. Doesn't look like we got anything. So that's my demonstration. Sorry we got started a few minutes late, but these are the kinds of displacement and biasing techniques that I've been using lately, specifically in UT. I'm sure I'll be using them a lot more in other things going forwards. As always, thank you for watching. I hope you found it entertaining and interesting, and tune in again next time for the next Twitch stream. Thank you very much.